So how do we check for homogeneity? We're generally given an equation which we wouldn't know whether it's correct or not. Say for example we're given E is equal to mc squared. Now E there stands for energy, m for mass and c for the speed of light. So what we're generally going to do is divide our work in left hand side and right hand side. So remember, we do not know whether this equation, or we need to assume that we do not know that this equation is correct or not. We are actually trying to check whether it is correct. So for the left hand side, we've got energy. So the main thing to do here is to try and come up with the base units for energy and check what the base units for the left hand side are. Then try and come up with the base units for the right hand side and see if the units, rather base units of the left hand side and the right hand side match up or not. So for energy, we need to come up with an equation for it. I'm going to go with kinetic energy. Any equation for energy would work here. I just chose the one for Ke. So from our previous work, we know that half is a dimensionless constant, so we just do not convert that into base units. Mass is a base quantity, so we just give that a kilogram. However, velocity is not a base quantity, and that we can actually break down further into velocity is equal to distance on time. Now, displacement on time, both displacement and time are base, therefore we can actually write down its base units. We're using these base units here, meters per second, however the velocity is squared, therefore all of these units are actually squared, and that leaves us with kilogram meter squared divided by second squared on the left hand side. So these are the base units for energy. Moving on to the right hand side, we've got mass and c squared, which is velocity squared. So the units for mass being base quantity, therefore we can just write down its base unit, is kilograms. C, we said, is velocity. And we've already shown that we know how to break down velocity in its base unit. So we can simply just copy those down there. We don't need to show our working again. Therefore, meters per second for velocity of light, however, all of that is squared. And on the left hand side, we end up with such base units. Now, if we have a look at what we've got on the right hand side and what we've got on the left hand side, the base units in this case are the same. Therefore, we can say that the equation is homogeneous in terms of base units. So let's just take another example and again check for homogeneity. Let's go with another correct equation. So the base units on the left hand side must be equal to the base units on the right hand side. This time I'm taking V is equal to F lambda, where V is the velocity of a wave, F is the frequency of that wave, and lambda is the wavelength. Again, divide our work into two, left hand side and right hand side. So for the left hand side, we need an equation for velocity. An equation which is not this, obviously, because this, we have to assume we don't know whether it is correct or not. So we need to choose an equation that we know is correct. And for velocity, there's a very simple equation which we can use, that is displacement on time. Now, the units for displacement are the meter, and the unit for the time is the second, and that is all we need to do on the left hand side. For the right hand side, we've got F lambda. Now F is frequency, and that is not a base quantity, so we need to open that up into yet another equation, which would be 1 divided by the periodic time. Now 1 doesn't have any units, however t is actually representing time, and therefore that is a base quantity. So we can simply write its base units. So 1 over second is the units for frequency. Width Lambda is wavelength. Okay, so it is the length of one wave. And if it is length, it is a base quantity. And therefore, we can simply just list down its base unit. Therefore, lambda is meters, and frequency, therefore, is given in 1/second. And what we end up there with is meters per second for the right-hand side. Comparing both sides, we've got identical base units, and therefore we can safely say that our equation is homogeneous in terms of base units, and that is our final answer.